Hello guys, this is a tutorial about how to do tracing in Unreal Engine 4. I'm using the third person template and I'm gonna go through the C++ way. If you want to learn the blueprint way, there are plenty. But if you wanted to get some, C++ ways, I wonder why they don't have that much of information on those kind of stuff. It's just disappointing to me. I think that the programming way is still the most convenient way to me. At least it feels like you have more control and it's just easier to figure out the logic. A blueprint is nice and fast. It's extremely fast to prototyping, but it can get complicated and hard to understand really quickly because all the lines connect here and there. So anyways, so let's go over the C++ ways of doing the the line tracing. First of all, let's go create a actor. So let's go to the add new and the new C++ class and let's do actor. And then let's call this maybe trace actor, tracer, right? Tracer actor. Cool. Create class. Okay, that will compile it and then bring up the Visual Studio. Let's go to the header file of our new actor. Let's create a new U property. Let's call this one, let's create a mesh representation of the actor. So let's use a skeletal mesh component pointer, mesh component. The reason I use a skeletal mesh component is I just wanted to use this one and it is a skeletal mesh. Anyways, so let's copy it and go to the constructor. Mesh component equals create default step object and then use skeletal mesh component. Of course, the name will be anything. So let's call it. I always name the same thing, so mesh component. If you're wondering how I go from the header file and by using some shortcut and directly go to the constructor or the function I'm selecting here, member function I'm selecting here is I'm using something called the Visual Assistant. Okay, and this one can give you very fast things searching method. Like if you want to go to the actor, right, just double click on it and then press Alt G button and it will bring you to there real quick. Go to the any member function. It's almost instant. It's much faster than the native Visual Studio way, and it's not a very expensive plugin. It's around $99 or so, so I think it's totally worth it. Okay, anyways, so let me go to the mesh component, the constructor. I want to load that mesh, so first of all I need to know where the mesh is. So let's go select our model and then go search the mesh. That's the mesh it's using, and right click on it. Let's copy the reference and then let's go back to the constructor and then create a static constructor. Wrong. Typing constructor helper, namespace constructor helper, app object finder, and then let's we're finding a use skeletal mesh, not component, just use skeletal mesh, and then we call it mesh asset, and then we're loading it from the address we copied. So paste it here. So it is a skeletal mesh. That's the location. Okay, and we get that and store it in a variable called mesh asset, and then this variable type is this object finder type, and this tab will be able to help you to find some asset in the content browser and then store it inside of it. Before we use it, let's check if this variable succeed. If we succeed, if we really find that asset. Okay, if we do find it, then we assign it to our mesh skeletal mesh component. So set skeletal mesh, and then the mesh will be the mesh asset dot object it's finding. Okay, so this object funded by the mesh asset in this location, or from this, file, will be assigned to our mesh component. Okay, quite simple stuff. The last thing I want to do is set root component to the mesh component. The root component is just the transformation component, or we shall say that the translation of this mesh component now is the translation of this entire actor. That's what root component means. Okay, it's the root, or the parent. If you're familiar with Maya, that's the grandparent of everything, the master controller. Anyways, so that is it. And then if that's done, then let's go back to the editor and compile. I should be able to see that it's still compiling. I should be able to see that my tracer actor now have a geometry representation of it. It's a skeletal mesh, and it's the mesh that is being used by the primary player too. Okay, that's the primary player, the first person player. Okay, the player. This one is using the same geometry. They're having different poses. That's because this one is using its animation blueprint, and this one is just idle. So, but we don't need that. So let's just keep it here. Okay. Now let's go, and then let's do. Let's make it swiping through the entire model, entire scene. So let's make it rotate. So let's do add actor local rotation. Okay, and then I need the F rotator to rotate. Oh, sorry. Oh, we're not doing it in the begin play. We're doing it in the ticking. So we rotate it a little bit every frame, and that little bit will be. I don't want it to rotate to yaw. So pitch. So pitch is 0. I want it to yaw. So yaw will be. Let's see, 100 or so, and multiplied by delta time, and then I don't want it to roll to. I just want to yaw. So it will. Let's see it in real action. Okay, so when that is done, let's go back and compile it. When I play the game, this guy will be rotating. Cool, and it's rotating a little bit every frame, depending on how long that frame takes. Okay, let's go back to the tick. Now I want to do a tracing, so let's do a get word, and then line trace. Get word is just the word where we're in. Okay, so line trace multi. There's so many line traces, and there are other traces like swiping, but let's do line trace because it's the simplest one. Other ones you can try it later. So let's trace. You can trace multiple things, or just stop tracing when you traced one thing. In this case, let's trace multiple things. So line trace multiple then, and then there is 3 different types. By channel, by object type, or by profile. So by channel, every channel can be, every object can respond to different channel differently. They can ignore that channel, they can collide with that channel, or they can overlap with that channel. So if you go use this channel, then objects that are actually overlap with the channel or collide with the channel will be considered. If not, then it will be ignored. and object type is similar. So every object have a object type, and if the object type, if you want to trace only the object that does have a certain object type, then you can use object type instead. Or every object have a profile name, so you can also use profile name instead. So there are so many ways you can do it. Okay, let's use object type. That seems interesting. Okay, and let's see, this len trace multi-by object type needs multiple inputs. First thing I need is a T array of out hits, and it's called out hits. That means that and it's also a reference. That's a very common thing in C++. It means that these out hits will be altered. The information you passed in, this out hit argument you passed in, will be changed. So let's will be changed, and the results will be stored here. The line tracing result will be stored in here. So let's create one. Fhit result. Oh, it's actually a T array of fhit result. The reason it's an array of result is because we're doing multiple, right? The multiple here. That's why it needs an array of that. So fhit results, and then hit results. Okay, and then we can pass in hit results. Okay, T array. If you are not familiar with Unreal Engine API, the T array is just like std vector in C++. I think it's C++11 std vector. They're very, very similar. Okay, so just use it as std vector and you should be fine. So hit results, and then start. We want to trace from where the actor is, so get actor location, and then we also need to get actor location. That's the end, right? So from the actor location, then we trace it in front of it. So get actor location plus get actor forward vector. Okay, and then multiplied by a big number. So we're tracing basically from the actor and towards the front of the actor to a very long distance. Okay, and then it needs a collision object query parameters. Before we do that, I think my list is getting super long. It has a very long list of arguments, so I'm just gonna organize them this way, so it's easier to see what I'm doing. So now I need a collision object query parameter, and I don't have any of that, so let me go create one. Collision object query parameters. Let's call this object parameters. Okay, and let's do that here. Now what this means, object query parameters is the information you want to, is the information to define the object type. Okay, so any object type you passed into this struct, okay, this structure, any object type inside or this structure contains will be considered in this trace. If we don't pass in anything, we just initialize it. It will call it a default constructor, and then it will allow anything to be considered. So we're tracing basically any object type for now. Okay, let's move on to the next one. Collision query parameters. Okay, so I need something like that too. Collision query parameters. Let's call it. I think I typed it wrong. Oh, it did that. So query parameters. So what's this mean? Now a query parameter is just some details about how do you want to query it. For example, here we can define something like we want to call this query See, it needs it has so many overloads of the constructor. Let's just do this one. Okay, so in trace tag, let's call this trace meaning tagging this trace. Let's call it tracing for fun. And then let's see, another thing is, let's see, you can press up and down to go through different different overloads. And then let's call it this one is in-trace complex. So object can be calculated collision wise as complex or simple, and that's also can be defined here. If you want to trace object that is using complex, then you use complex, otherwise you use simple. So for now, let's use complex. It seems more accurate, so let's use true instead. And then the last argument will be in ignore actor. What actor do we want to ignore? In this case, we don't want to trace ourselves, so put in this, which is a pointer to the object, the actor we're doing now. All right, semicolon to finish it. And then how do we know we hit something, right? It's very easy to do. If you hover your cursor here, you see that this function line trace multi by object type returns a true if any hit is found. If you go there and go to the if you go to the header and then see this one, it does return true if anything hit is found. So let's go back. To go back and forth, you can press Control Minus to go back, Control Shift Minus to go forward to the locations you were before. So very convenient. Line trace multi by object tab. So what we want to do is we want to create a boolean to store that information. B is a hit equals that. Okay. Now, if this one is hit something, if that trace hit something, then we just make things simple for now. Let's just print something on the screen. If you want to do that, you need to use something called the add on screen debug message. But it's actually inside of the gengine object, so we need to check if gengine exists. Always check if something exists, because it's not a managed language, and it turns to red. It's undefined. That's because in the header file of our game, which is the game name point h, my game name is collision, so that's the header file here. Let's change the include engine minimal to include engine. That way we're using the entire functionality of the engine, so that way gengine will be there. Okay, so gengine add on screen debug message, tag it to key it to -1. I don't know what that means. 5.0 is the time. Have color red color, and then debug message. I hit something. Okay, when that is done, let's go back to the editor and compile it. So basically what we did is we traced a line in front of this rotating actor every frame, every tick, and then we see if we trace something. If we trace something, we just add on screen debug message. Okay. It's still compiling because I changed the header file of the game from including engine minimal to engine, so there is a lot of things to calculate, but yeah, it's done. Let's go play, and you see it's printing. I hit something so many times because there are so many things inside of the level. So let's go back, and then let's do something more interesting. Okay, so if we hit something, then we do a let's do a for loop. Let's do a for each loop. So I've hit results, remember the hit result here we did? That's the output from this trace, right? We're passing by reference, so anything changed here, which it will be changed inside of the line trace multi by object tab, will be changed inside of it, and because it's a reference, it's changing this one also. So this one hit equals oh sorry, for that in the hit results, we're for eaching it. So for everything inside of the hitting result, which will be populated by the trace mod by object type when it hits anything, then for every hit we got, we say that let's see, maybe we can get the name, can get we can get f string name of object equals hit dot get actor, and then dot it's a pointer, so get name. So the name of the object will be placed here, and then we print the name instead. So if gengine and gengine add on screen debug message, and then -1. Oh, I know what -1 means. It's like layering. So this text will be layered on -1 layer. Maybe color display. Color, let's use the red again. And then let's see. I hit plus the name of object. So we hit something with the name of that. Let's compile it. Play. Now see, I hit something here. I hit the third person, which is the one I'm controlling. Hit this there and something like that. So it's hitting at like everything. Okay, let's go back, and then one thing I wanted to see is that I want to actually see a debug line. So I see where the tracing is. So let's do a draw debug line here. Okay, and then we're drawing it in our word. So get word, and then vector let's start. That's gonna be our actor location. Okay. And then vector line end, that will be the get actor location plus get actor plus get actor forward vector multiplied by a huge number. And then let's see, color. Of course, color will be, let's use green. And then persistent lines, let's make it false. And then time, left time, let's use -1 also. Depth priority, which I think that's the layering thing too, let's use 0. I think it's uint 8. It's a very smaller sized tab. We use int. It's okay we use int is because it can be implicitly converted into that format, and it's 0. And then thickness will be let's try 10. I want it to be very visible. Okay, cool. Now we have a line trace. Let's go back and compile it and see how the line trace looks like. It should be a green line tracing from the player. Yeah, like that. Cool. That way it's easier to see what is being traced. Alright. Now I don't want to trace anything here, so let's see what else I can do. Maybe I just want it to be tracing my controlled character. Okay. Now I know that the object type of this character, if we go there and check it, underneath the collision, collision, okay. Collision presets, our object type is pawn, okay. So if you wanted to only collide with pawn, then we need to go back there and define that. Okay, so to do that, we need to go and then inside of the object query parameters, which is this one we create, right? Now instead of only making it colliding with anything, we can actually just define it. We're using ECC. We're only tracing, we're only concerning the pawn object, ECC pawn. It's the tracing channel, okay. And then let's go back and then compile it. That's telling the trace here that this object query parameter defines that only the object type, only the pawn object type will be considered. Other things will be ignored. Okay, let's see. Now if we play, now only when it swipes me, it print that it actually hit me, but it doesn't hit anything else. Okay. If you're coming from Unity, you're probably wondering, okay, we use tag there, right? Let's see if we can use tag too. Anything should have can have a tag here. Let's search for a tag. Okay, and we can add tag too. Let's call this player. So this one have a tag of player. Okay, just a string. Okay, now it should be different here. So instead of only tracing CC pawn, we're tracing anything, but we check if the thing we hit has tag, right? So if gengine and hit get actor has tag, okay, and then we push in the player. Okay, so if this actor has tag that's when we print something. We're still tracing everything, we're getting everything from the hit, but we only print the thing that does have the player when the thing we're tracing has the player. Okay, player tag. So let's go and then compile it and then play it. Now it does the same thing. Okay, so you can use tag if you wanted to, but the thing is could be expensive because you're using tag. So in here you're tracing anything, that makes the tracing heavier. I think it's making its line trace heavier. Anyways, so let's go back to try to do something else. So instead of using the tag, let's go back to use the object tab, because that's why I'm using this, right? So object tab. Let's see that I want to create a custom object tab. Okay, and here in Unreal Engine, you need to go to Window, Edit, and Project Settings, and there is a collision, and then you can add object tabs here. So let's add a new object tab. Let's call it Player tab. Accept. Okay. The default behavior of this one is blocking, so it's gonna be able to be traced. Okay, now let's go and then change our let's get rid of this element. Let's go to the collision, and then instead using the presets, let's change that to custom. I want my object type, instead of pawn, I want to use the new type I created, which is I thought I have that. Let's go to the settings, and then project settings, collision, player tab. It is it. I don't know why it's not showing there though. Oh, it's was static. It's not updating. Let's close the editor, and then let's compile it. I don't know what's going on. I just add an object type, but it's not showing. Object type, but it's not showing in the list. Something was terribly wrong. Don't worry. I don't have the VR, so let's close that. Anyways, let's go try to change it again. Make sure I have that. Collision tab is player. It's blocking things. Okay. Let's see. Go to the collision presets, and then now I can see the player for some stupid reason. Alright, so the player is now here. Alright. Now if you go to play, it's not tracing anything, but now I want it to be only tracing the player. But in the code, if we try to do the thing we did before for the pong, which is we did ECC pong before, right? Let's do ECC player. There is no ECC player because it's something defined in the editor, and then the editor, the actual C++ code doesn't know that thing exists. So how can we relate those two then? If we go to the config of the game engine, okay, the configuration of the game engine, which is the default engine here. So you see that there's a lot of things listed here, okay. And this line right here says that the default channel response equals ECC gamer channel game trace channel 1, and its name is player. That's actually the player channel, the player game object tab we created. We can actually create something ourselves here. So let's copy paste, and let's make it ECC game trace channel 2, and let's make this one whatever. Save it, and then of course I think we need to restart the engine because it's a low-level language. It cannot be really that flexible. Oh, sorry, I have a compiling error because I haven't put anything here. Let's just delete that to make it trace everything here for now. I don't have VR. I hope I have one. Okay. Anyways, so now if you go to the list, we should be able to see that whatever inside the list too. Let's go see. No. It's a person. Search for collision. Now you see we have this whatever, right? So that is that. Notice that in the project settings, and then the collision, that's a object channel, right? And we have also trace channels, but if you add a trace channel, it's actually doing the same thing. So actually I think that object channel and trace channel, they are the same thing in the code level. It's just represented differently in the editor. But anyways, so to refer that in the coding, what we need to do is find this channel here. It's called ECC game tracer channel. For example, the player is tracer channel 1, right? Let's copy this. Okay. and then go here and then actually paste that in here, and this one is actually representing the player type here. Okay, let's go save it and then compile. Now I should be able to see my player being collected with player tab. Okay, cool. So now anything have the player tab. For example, that one, if I give it a player tab, that cube will be also collected. Okay, cool. So that was easy, but this is really hard to know what that means, right? Look at this. What does this mean? It doesn't make any sense. It's really hard to relate to what the to relate to the actual meaning of player here. So that's not cool. So one thing to fix that is that we can use a macro. So inside our header file, engine head file, let's go into the macro, and then let's go to create a define. Let's call this collision. Oh, actually, just ECC should be good. ECC player, just making the naming convention consistent, and that will be no semicolon here. We just define that as that. So every time when I put in ECC player here, every time when I put in ECC player, it means ECC tracer channel. That way that I know I'm doing the player. So let's replace that with ECC player and then compile it again. Now this time it will do. Also the same thing. And it's just easier for you to figure out, or for other clients to figure out, what do you mean by ECC channel 1. Every time you do that, it kind of takes a little while to compile though. Okay, let's do play again. I see it's still doing that. Even I changed that to ECC player. Okay. Now let's change this from player to the whatever I did. Okay. Of course, it will not be affecting anymore. And I wanted both player and the whatever to be traced. 2 categories. So how can I do that? Well, in object collision parameters, there's one constructor that has an array of tabs, and that's what I'm gonna use here. So I need to construct it differently this time. And you see that it does need a let's put it here. You see that it does need an array of enum as bat and object tab query. So first let's create some object tab query. To do that, what I need to do is a object tab query. Let's do this one is the player one, and then I need to convert my ECC player to this object type, and there's a very convenient function called uEngine tabs. Underneath uEngine tabs namespace, this one called convert to object tab. Okay, now I can type in ECC player. So that's one. And then let's create another one. This one, let's call this whatever, right? That's the whatever one. Equals uEngine tabs convert to object tab. Okay, ECC whatever. Oh, I don't have ECC whatever yet. Let's define that. copy it, and then ECC whatever. So now I have two that's object query type that I want to refer and to trace. So I need to create that T-array that is needed. It's called the T-array of T-enum as type. This is just when you wanted to refer to this, you will use this container template for that for some reason. So let's do T-array T-enum as bad E-object tab query. Let's just create this T-array called the object I want to query. Okay. Now let's do object I want to query, and let's push it. If you're familiar with vector, you know what push is. It's just adding a add-on to this array. So we push the player in. Okay. And then let's push another one in. Let's push our whatever in. Okay. Now the object tab will be pushed. Object tab to query will be pushed. We'll have two elements: player object tab and whatever object tab. And I want those two object tabs to be considered. So instead of using ECC player here, let's use this object tab array to represent that I want two tabs to be considered. All right. So when that is done, let's go back to the collision and then compile it. Oh, every time I have defined something, it's always slow for some reason. So basically what we did here is we create an array of object tabs that we want to query. Okay, I think this is not really clean for some reason, but I need to define the two. I need to create those two tab queries. Okay, there's two enums, and then put those two enums into an array like this by using pushing. So two enums being pushed to an array, and then that array will be then used to initialize the object query parameters as the tabs I want to query. So, you know, I don't think it's clean enough. I think they need to do some change on that. But anyways, or maybe there are other ways. But for now, right now, I can actually trace two things. Oh, the other one is not being traced. Let's see what's happening there. So this one has whatever tab. Okay, it's blocking everything. Yeah, it's custom, and it is here. It's pushed to whatever, so it should be able to do that. Let's see. Nothing here defines the trace tab or anything. So let's object query parameters is this one. Tab to query is that. Okay, maybe I need to reopen the editor again, because that's, you know, always happens. So let's try that again. Hopefully this time it will work. Oh, you know what? That's because I didn't make it channel 2. The next one will be channel 2, or you can check the default engine here. Totally forget that. So that's why. Okay, so when that is done, I should be able to see that both of those objects should be traced. So my character and the cube. Oh, not yet, because I haven't compiled it yet. it's gonna take a little while too. This time it takes longer. Alright, let's do play. Now it can hit me, and it should be able to hit that cube too. Even we have different tabs, but we have both those tabs considered by using that array of object tabs. So any tab inside of that array will be considered and will be traced. Okay. So that's a little bit more detailed. Okay, now one more thing. When you're tracing something, you can actually trace another very important aspect of an object, which is called the physics material surface tab. Anything can have a physics material, and that physics material can have a surface tab, and depending on the surface tab, the different of surface tab, you can do different things. So I can actually use the trace to tell me what the physical material surface tab is. That way, for example, if I hit some component that have a different surface tab, for example, I think the most interesting example will be like first-person shooter. When you shoot the head of the enemy, you want it to die immediately, but when you shoot on the arm or maybe on the chest, there are different area on the body, and you want to have different damage on them. So that is really easy to achieve by using physical material surface type. You can just define different surface type on those different parts of the body, and that way you can then make check the surface type and then make the damage different. Okay. So surface type. Actually, let's do that. Let's just make it higher. Okay, let's just make it swiping, and when I want to make the swiping, when the swiping is swiping the head, I want to print your dad. If I'm swiping the chest, let's do your hurt. Okay, let's print your hurt. Let's see how we can do that. Okay, the first of all I need like two surface tabs then. So let's go to the settings, the project settings, and then underneath the physics, and you will be able to find the surface tabs. Okay, let's define some of them. Let's define this as head, and the other one, let's define it as body. Okay, head and body. So we have now two surface tabs. And let's select our geometry and go to the skeletal mesh component, open it, and then go to the skeletons. And then you can choose the skeleton, sorry, the mesh actually, a different part of the mesh. And then somewhere, let's see, oh, not there. It's in the skeleton. And oh, you know what? That should be in the physics asset instead. That was being stupid. The physics asset should be containing that information. So every little physics asset here should have a let's see, physics tab. Oh, sorry, not there. Physics material. We don't have any physical material yet, so let's create two different physics materials. So I think it's underneath physics then. Physics material, and let's call it one head. Hit Control C, Control V, and this one will be chest, body. Okay, so two different physical materials. Let's open this one. The head one, I want to define the surface type here to the that is the head. This head is defined earlier. Oh, sorry. A project. Not here. Sorry. This type is defined earlier inside of the project setting. Underneath physics, and then here the head and body. Okay, that's where we define it. That's where we can actually assign it to a physical material. Okay, and save off. Go to the body, and let's change the body type to body, of course. Save. Okay, now inside of the physics asset, let's grab all the joints and then let's change them to physical material to body. Okay, and then let's go grab the head, and that's why I wanted to change it to head. So this one, so for now I only have two different physical materials. The head has head physical material, the body have body physical material, and head physical material has head surface type, and the body physical material have body surface type, and that way I should be able to, you know, differentiate them by using the surface type. Okay. Now let's go to the oh, you see it's updated. Let's say if this, so the thing has been updated is the default engine, because it does have added those two new types we added. Let's see, where is that head? Oh, those two. See, the head and body is being updated here too, and you see the surface type 1, surface type 2, right? It's identical. It's almost identical as those ones, ECC trace cameras. So let's define that then. So head is surface type 1. So let's go to our header files. Let's define those two. Define. Got some weird information. Okay. Need to reply something. All right, so we're defining surface type. Let's call it surface head as surface type 1, and then I'm sure that the other one will be surface body surface type 2 then. Okay, so both of those things are defined here, so we can use that instead of the weird numbering thing here. All right. Now, to trace the surface, the physical attributes, in the collision parameters, you need to define that. So let's go there and check. Query parameters, it's the parameter we passed in, this one, right? We passed in here as defining how we query stuff. And then there's one called B, return physical material. Okay, this one will be true, so we're returning the physical material then. All right. Now let's check when we finish the heading. Let's do the physical material pointer. Oh, sorry. Physical material equals hit dot get physical physical material dot get. Okay. Now let's see if GEngine and physical material dot surface type equals surface head I used semicolon again, which is stupid. Preprocessor does not really need that, so that's no arrow. Let's just say that you died. I hit your head, you dad. You're dad. Alright, then else if GEngine and physical material surface type equals surface body. Then we GEngine again. We add on-screen debug message again. Let's call it this time we're saying that you're hurt. Okay, so that way we're detecting the surface tab and do different things based on the surface tab we hit. Okay, now let's go back and then compile it and then try that. It may take a little while. Anyway, so basically what we have is we have different physical materials on its body. Okay, and then they have different surface types, and when we hit a different part of the body we get different types, and then depending on different type we're getting, we print different things. I don't want it to be like that. I don't want to control my player and directly. Let's go to the simulation way. Okay, so I hit your head, you're hurt. I hit your head, you're hurt. That's not the head. Let's see. This one is the body, but it's considered head. I think that could be because that the collision type here we're using the complex collisions, so I need to also make the complex collision to be count. So that means that I need to go to the and then simple collisions. Simple collision physics material. I think that's something we need to do. So let's also change that then to the body here, and then change the head to the head. Save it, and then let's play again. That's hitting the head. I hit you, head, you're hurt. Oh. Let's make it high. Okay, I hit your head, you're dead. I hit your head, you're that's just some printing thing I didn't do correctly, I think. So that's I hit your body. So nothing actually was wrong, I guess. So I guess we can change those. Those are for simple collections, but we're doing complex collections, collisions. So I guess that's okay. Just to be super sure, let's go disable this one I changed. Clear it. Save the asset. Let's try that again. So I hit your body, you're hurt. I hit your head, you're dead. That way, depending on different part of the body, you get different results. Okay, so that's a little bit more detail on variations you can do with collision. And I guess that's all I want to go over for this tutorial. It's already 1 hour. We have went over a lot of things. Custom types, I think, is a lot of things to get used to. And but I think that should be able to help you to do a lot of things already with the tracing. And of course, you can use other tracing. Instead of land trace, you can use something called the sweep. Sweep modded by sweep single or multi things, meaning if you're hitting one thing, you stop when you're using the single. But if you use multi by something, then you trace all the way and you hit multiple things. Sweeping can sweeping a shape on it, which is cool. But anyways, I think that's too much to go over already. So that's basically the collision tab, object tab, surface tab, and stuff. So just to be super complete, let's go to project settings, and then in the collision, this one called the trace channel, we can add, for example, the weapon trace channel. People use that a lot. Okay, if we create a new trace channel here, okay, let's do yes to all, and you see that in the default default engine, that it's gonna be assigned with game trace channel 3 as the weapon. You see that the player, whatever, and weapon, although they're defined as different things, right? This is object tab, this is trace channel tab, but they're essentially the same thing in the coding level. They are the same thing. So if you want to use any tracing channel, you can also use in the same way as exactly like how we use the object tab. So you can define ECC weapon, ECC game channel, it's being assigned game channel 3. So every time when I refer to the ECC trace channel, I can use ECC weapon here, and that will be represented as a weapon channel defined, here in the collision presets, the channel, where is the weapon? I think I need to reopen the file here to save it. Need to recompile it. I guess that's because I have this file also opened in the Visual Studio, the default engine file open here, so that that's preventing it from actually applying it. Even I do applying it here, it's not applying it in the editor anymore. So that's probably why. But anyways, in the collision presets, let's just do anything. So now you see that you have one more collision channel called whatever, right? And that's the collision channel. That collision channel will be represented in the coding for now, because I define it here. I can use it to represent that. Where's the one? It's disappeared again. It's like, oh, it's here. Actually, I'll be representing that. Okay, cool. So that is it. And thanks for watching. I hope I can do more in the future. This tutorial is not only like for all the viewers, but also for me. I'm documenting the things I've learned because I have bad memory, so I always forget things. So I think recording it for me to review later when I forget it is really useful too. So I always keep note of the things you did. I think that's really important. Okay, so thanks for watching. Actually, one more little thing here. If you guys encountered with something like this, for example, I have this cube, right? And I have those things already there, those tabs already there. So let's change this one to have a physical material. Did I type that wrong? Physics is here. Oh, physical material override. Let's use a body here. Okay. Now, according to my code, I should be able to make that one cause something too when it's getting hit, because we convert to object type. Yeah, we have whatever, and it's of type whatever. So, and it does have the physical material, whatever, right? And the physical material. Come on, it's down there then. Am I being bland or something? Physical material. I just changed it. Maybe it's on here. Override. Oh, physical material override. Okay, so under this collision. So I changed this to body. So when the scanning goes through the back, I should see the same thing. Let's try that. Oh, this one is, I guess, static. Let's change that to move. But it doesn't really do something when it's swept. Why it's not doing anything? I do have a physical material, right? The reason for that is because this box is collision. Let's go to the collision. It's really hard to see. Let's just search for simp complex. No. Let's delete it, and then let's find it in the content browser. Oh, it's not even in the content browser. Oh, it is. So let's go to the actual setting of it. Now there is a collision complicity. Okay, and right now it's used project default. It's used I don't know what setting it is, but if you change that, use a simple shape for all things queried and collision test. Okay, and then save it, and then let's go do it again. At this time, it does reflect to the surface. Okay, so you need to be really careful about this. Very little detail about, because the tracing, it's having only a simple collision, I guess. Okay, and then but what we're tracing is here in the tracing settings where this is true. This one, if you see what this is, this true means we're tracing complex, right? In trace complex, that does have to be true here because I want it to be. And then if that is true, then here you need to change that to use simple collision as complex. Okay, that's what that is. Okay, cool, and that should be it.